With the latest 3D printers and CNC equipment becoming more affordable, implementing the use of technology for making custom car audio parts is now more attainable than ever for both car audio shops and DIYers. The thing is though, in order to design these parts that are installed into the vehicle, we need 3D model data of the vehicle, which of course comes through 3D scanning. Now, vehicle interiors themselves pose a unique challenge when it comes to 3D scanning, as they often have dark and reflective surfaces. This requires higher-end scanners that use blue laser line technology if we want to avoid the use of scanning spray. Up until recently, a scanner that has this functionality could easily be between $5,000 and $10,000. And that's before you factor in the cost of the software. That's why when I saw the Revopoint MetroX scanner about a year ago with its under $1,000 price tag with included software, I knew I had to try it. So we did in a recent video, and the results were incredible. Extremely accurate scans via an easy to use scanner and software. But it turns out that Revopoint saw that video and they said, "You think 800,000 points per second in that crossline laser mode is fast? Wait until you see the bigger brother, the MetroY Pro, with its staggering 1.7 million points per second." So that leads us to this video. Revopoint saw all the awesome community feedback from you guys on that past video and wanted to sponsor this video so that we can take a closer look at the MetroY Pro. So a big thanks to them and to you guys for making this happen. Let's find out what's all included with the MetroY Pro, what advantages does it have, I am dying to try out the wireless functionality, and what kind of results can we achieve with some test scans for car audio projects. Let's find out. Kicking things off here with an unboxing, of course you have to realize that a 3D scanner is a precision piece of equipment, so we want to keep it in a nice, robust, strong case, and Revopoint has provided that for us with this case for the MetroY Pro. In the top here, behind this protective piece, they've given us an accuracy inspection result, the quick start guide, a warranty card, some scanner targets, and in this protective bag right here, the calibration plate. In this compartment here is the MetroY Pro scanner. Next up, a USB cable for, of course, data transfer to our computer, but do remember that this is also enabled with a wireless connection, which we'll talk about more later. And here is also a power supply. This is what we would use if we are connected in wired mode. Now, since this is the MetroY Pro, they do give us all of these pieces here for the mobile kit. It is worth noting that the MetroY is compatible with these parts as an upgrade. The handle here is actually a battery which we can use to power the scanner wirelessly, which connects via this cable here. And they also give us this bracketry that can be used to secure a mobile device in mirror mode. Another component that is unique to the Pro model is the dual axis turntable here. Inside it has its associated parts. They also give us a small tripod that we would use in conjunction with the turntable, a cleaning rag, and a small sample part to scan. Now before we get into doing a calibration and a test scan, let's first take a close look at the anatomy of the scanner itself. First off, on the back side here, a nice textured grip. That way we can maintain good control if we are holding it in this orientation. You can see there are 4 different buttons here. These have a nice tactile feel. We've got the start and pause scan button. We've got the increase depth exposure and decrease depth exposure. And then we also have the menu button. Down here at the bottom is the USB-C port that's going to allow us to connect to a computer or to a power supply when we are operating wirelessly. Along with a small vent, there is a fan in here that keeps everything cool while you are using the scanner. On the front side of the scanner here are 6 blue fill lights on each end along with each depth camera. There's an RGB camera right here which allows us to pick up color for our scans if desired. Here is the multi-line laser projector. And finally, since this is the Pro model of the MetroY, this also has the structured light projector here. So before we do our first scan, it's always a good idea to do a calibration. They of course calibrate this at the factory, but it's a good idea to calibrate in our actual scanning environment and just to make sure that everything is up to date. I've already got the Revo Metro software installed on the computer. Again, free software. It was easy to download from their website, easy to install, and now we're going to go through our first calibration. So we'll click the start button down here for scanner calibration. And what I love about the Revo Metro software is everything is always explained to us very easily. So first we need to kick this off with scanning this QR code. And now it's going to walk us through every step of this process. So if you're someone that is new to 3D scanning, I love this because it explains every aspect of what you're doing, which is going to come in handy later for when you're doing an actual scan. So there we have it, our accuracy check has passed, so now we can save the calibration result. And just as a reminder, keep in mind the calibration process is something you only need to do every once in a while. You definitely don't need to do this before each scan. Now for our first test scan, we're going to scan this A-pillar. Obviously modifying an A-pillar is something that we would commonly do in custom car audio in order to add a speaker pod or maybe to make some sort of modification to this tweeter grill right here. But nevertheless, we did scan this in that previous MetroX video, and I want to scan this again in order to make some comparisons and see just how fast the MetroY Pro is. Now again, the MetroY Pro is a blue laser line scanner, which is advantageous because we can scan dark and shiny objects without any scanning spray, but we do need to add these scanning targets. The blue lasers also allow for extreme precision. In this case, we can get a precision up to 0.01 millimeters, which is insane. We're going to test that out later. Now, a few tips for you guys really quick on the targets. It's important that you put them on flat areas. You wouldn't want to put them on an area like this where it rounds over or on a corner. You want to try to keep it on areas that are as flat as possible. Obviously, there is some curvature here, but you wouldn't want to put on the edge or anything like that. And typically, you want the scanner to be able to see 5 different targets at a time in order to maintain tracking. And another tip for you guys, you can see that I've elevated this part off of the work surface. I do that because the scanner is going to obviously pick up the table as well, and this will make it a little bit easier for me to clean up the scan later. I can cut away and remove this table information, leaving just the A-pillar. Hopping back into the software here, you can see that we are connected to our MetroY Pro over USB currently. Again, we will test out the wireless mode in a little bit here, but we're going to start a new project. We will name this A-pillar. Now, what I really love about the Revo Metro software is they have all of these little information bubbles that you can click as you go if you're learning how to use this for the first time. That way you can get an explanation of what each of these little options mean. The first one I want to focus on for you guys is the target point distance. I know that it's easy to think, hey, I'm doing a 3D scan. I want to make sure I get as much precision and accuracy as possible, but you do really need to consider your application. In this case here, where I'm scanning an A-pillar, and let's say that I'm making a speaker pod to attach to it, I don't really need a ton of dimensional accuracy. I need it to be close, but it doesn't have to be absolutely perfect. It's not like I'm machining a part that is going to fit size on size for metal and have a press fit or anything like that. I just need it to have the general curvature so I can get away with using a larger target point distance when I do my scan, which is beneficial because it's not going to be as taxing on my computer. Now, in that previous video that we did on the MetroX scanner, for our scan, we did a 0.5 millimeter target point distance. And I want to use that same value just to get a comparison in speed here as we measure those 1.7 million points per second in our crossline mode, which we have selected here for this first scan. Cross lines, we're going to do marker tracking, and we're just going to leave our object type as general. Note that we could do a black object or metallic shiny object depending on what it is. In this case, more of just a general part here. So as I hold the scanner, I can see that I'm getting a preview over on my screen. We can see that it's picking up those laser lines on the part. So our depth exposure is good, our laser brightness is good. So I'm going to start this scan without actually touching the computer. I'm just going to hit the start button here on the scanner. So here we go, and holy cow, we are immediately getting a super fast measurement. Look at those 34 lines going to work. And what's critical to note here, as I'm scanning, you can see that that surface color kind of changes. It's kind of a bluish green. When we get that bluish green, what that's telling us is that we've completely measured that spot. And look how quickly this is measuring as we go. Now, if we do come across a spot that needs more markers, no big deal. We can just hit the pause button. We can add those markers as needed, and then we can resume our scan. Let's do that right now. Just watch how quickly it picks up this area to the right as I scan. Here we go. I mean, we are getting a beautiful result virtually immediately as we go. Something else you can do to help the scanning speed is you can add these little marker blocks. Revopoint also sells these, but you do need to keep in mind that if you do have these marker blocks around the part, like I have here, you need to be very careful not to move the part in relationship to the marker blocks because it is part of the tracking while you are doing a scan. So although we can easily make a scan without these marker blocks, let's just show the quick benefit of using them. I'm going to start the scan once again, and this is just insane how quickly all of these points are being measured. Look how quickly it adds in that surface as I go along here. The sheer speed of the MetroY Pro is absolutely insane. Let's really make sure we kind of get underneath the handle here at an angle. Notice that I'm moving my hand really smoothly, kind of like a gimbal, like a camera gimbal would be. Let's just make sure that we got every aspect of the edges of this here. This is going to be a really nice scan. Now do keep in mind that there's other modes we can use. That first mode was the 34 crosslines mode at 1.7 million points per second. Now when it comes to measuring more details, it is advantageous to use this 15 parallel lines mode. And for areas like this on the part that have a deep hole or crevice, sometimes it's hard for the cross lines or parallel lines mode to measure, and that's why they've included a single line mode. Now the difference between the MetroY and the MetroY Pro is the Pro model has a 62 line blue structured light mode. This mode is used for items that have a lot of features, and it actually measures 7 million points per second. The Pro model also allows us to use the auto turntable mode. Now it's great that the scanner is fast, but we also want to make sure that we can post-process our scan quickly and efficiently as well. Here you can see we have our scan of our A-pillar, and keep in mind this was at that target point distance of 0.5 millimeters. If we hit complete on our scan, you're going to see that we do have some points floating out in space, but we can easily clean those up. Let's head on over to our Fusion. And again, if you're new to 3D scanning, you can easily see what these mean by hovering over them. This is going to merge the scanned multiple frames of original 3D point data into an overall point cloud model. You can see that they have a recommended value for our point distance here, which we can match. And for this case here, we're just looking to optimize our speed. We're going to do a fast fusion. This says 2 minutes, but I find that typically it's done a lot more quickly than that. It's already down to 1 minute. So once we've done our fusion here, you can see what the surface looks like. And it is worth noting that we do have an option over here that we can remove the markers if we would like. Doing so is going to add holes in our model, which you may think, why would I want to add holes in the model? No big deal. Later, what we could do is do a mesh edit to fill those holes back in, and it's going to take an average of the area around it and kind of match the curvature naturally. Now keep in mind we are still in the point cloud editing section here, so we can do isolation of the point cloud. That's going to allow us to remove any of the data that is disconnected from the main body. And you can see we can play with the percentage here, so let's try turning it up a little bit and detect again. This can allow us to remove some of this extra information, but what I like to do, remember that we made our model where it was floating up above our worktop surface, so a better way to do this is to click this button here. We can select our part, and now we can invert our selection, and now we can simply hit delete and remove all that unneeded point cloud data from the table itself. Now again, keep in mind that this is going to be application dependent on what you're looking to do. I could even cut away some of this unneeded information. Let's say I was only focusing on the lower part of the A-pillar here. In this case, I'm going to leave that information in place, but do pay attention to the points here as well, the points that we've measured in this point cloud. We can simplify the point cloud if we would like as well with a uniform downsampling. And again, keep in mind that everything that we need to do here is explained in each of the different sections, which makes it super easy. Simplifying the point cloud can be advantageous, just like it is to simplify the mesh later in the process. That way we don't have as huge of a part when we go to import this into our modeling software and design. You can see in this case we dropped from about 1.8 million points down to just north of 1 million points. And another thing that I really like about this software is if we ever do make a change that we don't like, we can simply undo it. I'm going to leave it at the 1.8 1.8 million points here, and we're going to move over to our mesh section. And in this case, we are again going to do the faster, more efficient mesh. We're going to go with fast mesh. So for my case here, that fast mesh process completed easily in under a minute. And do keep in mind how quickly this process goes is going to be dependent upon how powerful your computer is. You do need to have a relatively powerful computer, which if you're doing 3D modeling and design, odds are you're going to have a more powerful computer as is. But if you do want to learn more about the recommended specs for a machine for your MetroY Pro, you can check those out on their website. So now that we have our mesh here, we can take a little bit closer look, and look, we do end up with quite a bit of detail even at the not maxed out settings here. But let's say we do want to fill those marker holes from before. We have two different options there for plane or curved. I'm going to use curved. So all the green spots are spots that the software has detected a hole. Now I need to tell the software which holes I would like it to fill, and that's going to be all the holes that are around the markers. So I'm going to do a select all really quick. And because there's actually less that I don't want it to fill, so I don't want it to fill these actual holes that we have in our part there, but I do want to allow it to fill the rest. So let's go ahead and apply. So there we go, it's filled in all the holes. Now, of course, you can kind of see them in the model here, and that's because it fills it in with a perfectly smooth surface. If we do look at it from an angle here, I want you to watch kind of the edge of the line here where it turns to black. As I orbit around the part, you're going to see that it's not actually sticking out above that surface. Like if you watch right here where there was a marker, we can see the marker in the mesh here, but it doesn't actually extend out over like it would in real life. But what's crazy is notice that you can kind of see a texture on the part. That's the scanner actually picking up the texture that is on this. So from here, we've created a mesh that we can export. And you can see that we can export this as a PLY, an OBJ, an STL, FBX, a GLTF, or a 3MF. So lots of different options here that you can use in your 3D modeling program to make your parts that are going to mate to this. Now, real quick, before we try out the completely wireless scanning and scanning a much larger area in the trunk of a vehicle, I want to see how far we can push the precision on this. I don't know if you guys can even really see this on camera, but this has a texture to it, and I want to see how much of that texture we can really pick up by maxing out all the settings and doing a super precise scan. So we are going to drop the target point distance all the way down. We are getting 0.15 millimeters now. Let's start our scan, and I'm really going to focus on this detailed area here. Now do notice that our scanning process is a little bit slower now, and that's because we are measuring with so much more precision. This is a much more fine point cloud, so it takes a little bit longer to transition from that orange to green color here, but you can see as I keep going back and forth on this surface, we are starting to get more into the green. And you can also see as I scan more of the model, it naturally resizes my preview as well. That way I know where I'm at on the part. I forgot to mention this earlier, but I also really like that bar on the right-hand side of the screen. You can see that you are getting excellent results based on your distance away from the part. If we get too near to the part, you can see that it's giving that warning there. If we get too far, same instance. But when we are in that excellent range, we are measuring good data. So in our Fusion tab, we're going to change this to the finest point distance we can, and we're definitely going to do a high quality fusion. Now, obviously, once again, since we have more points that we're measuring here, this is going to take a little bit more time to process, so this is application dependent. So after going through the point cloud edit and removing some of the unneeded data and going through the mesh editing, look at these insane results. You can actually see that exact texture that is on the part, along with all this added detail in the mesh area of the tweeter grill. We could easily replicate the look of this design for our tweeter grill by taking measurements in our 3D design software and replicating the design. Now, what about wireless scanning? So of course we do have this wire because we have to power our 3D scanner, but that's done with this mobile handle here. This is part of the mobile kit. And this allows us to do two different things. First of all, we can connect to the computer wirelessly. This is actually broadcasting its own Wi-Fi network that we connect to with the computer. And that allows us to simply use the same exact software on the computer without any physical connection. But the other super cool thing that we can do is use the Revo mirror software, which allows us to mirror the screen that we are seeing on our computer on a mobile device. Now, with the brackets that they include with that mobile kit, we could use our phone as that mobile device that mirrors our computer screen. But for the sake of making this video and having a little bit bigger screen, I wanted to use this tablet. Now, I want to point out something here that is super critical to understand. You cannot use the tablet or your phone to run the software. This is mirroring the software that is running on your computer. You still need the powerful computer in order to be able to capture the 3D scan data in the program. But in my mind, one of the coolest things about this feature is now if your powerful computer that you're using is a desktop machine and maybe it's not as portable that you can't bring it out to the shop and use it for scanning, you can connect to that machine wirelessly. Now you don't necessarily need to have a powerful mobile laptop. Like I said, instead you could use a desktop machine. To test out our wireless functionality here and to try out a different use case, we're going to be scanning the trunk of this vehicle. This is a Jeep Wrangler, and let's say that we were wanting to capture the area of this storage tub to use it for designing and making a custom subwoofer enclosure or maybe an amplifier rack, that kind of thing. You can see that I've already added all of these scanning targets here, so let's initiate this scan. So I'm going to leave my computer here on the workbench, and I'm going to take my screen mirror and the scanner over to the trunk. And here we are in the trunk of the vehicle, completely wireless, and I can monitor the software using the tablet. Also worth noting, I can change the program settings from the tablet here. Let's say I want to increase my target point distance. I don't need a ton of accuracy out of this scan. Let's shoot for right around 1 millimeter. Now in this scan, I am going to do something a little bit different. We're going to do the global marker tracking mode instead. And you'll notice when I'm doing this type of scan that I am only capturing the scanner targets. I'm not actually capturing any of the surface data at all. And the advantage of doing this for a larger area is we are programming all of those scanning targets first, which is going to make sure that we don't lose tracking as we go around this larger area. Again, this is super fast. I've virtually added all of these targets already in this small amount of time that I've been talking. So once we have all those targets, we can of course start our actual scan of all of our information here. And while we do this, you can see that we virtually never lose tracking because we already have all of these scanner targets programmed in. So here we are back on the computer now, and you can see that we've captured a ton of great data that we could easily use to design in this area of the vehicle. Even with this larger target point distance of 1 millimeter, you can see we pick up tons of detail here. And let's do a quick mesh on this. And once again, after removing some of the unneeded information in our point cloud, just to simplify the model a little bit, you can see that we have a really nice, completely meshed result that we can use for our modeling. And just as a quick side note, if you were wondering about some of these areas where we didn't pick up any information in the scan, I just needed to increase the brightness of the laser a little bit, but I wasn't really concerned about it because these areas here are just flat anyways. I'm more concerned about the areas here in the corners to capture that curvature that we need for actually designing our model. Same reason I didn't focus too much on trying to get information in this area here and some of the other spots on the model. Again, everything is going to be design and application dependent based on the data that you are looking to capture. And once again, keep in mind, if I was concerned about those holes, I could simply fill them in the mesh edit command. Now, overall, as impressed as I was with the Revopoint MetroX 3D scanner, really seeing it as an optimal solution for car audio shops and DIYers, I think that if you're looking for an even more efficient workflow with improvements to scanning speed, and if you like the idea of that added ease of scanning wirelessly, you're definitely going to want to check out the MetroY and MetroY Pro. To learn more, I have some direct links for you guys down in the video description. And once again, a special thanks to Revopoint for sponsoring this video. Thank you guys so much for tuning in and watching, and I will see you in the next one.